Hey everybody, welcome to my Friday question of the week. It's Geometry Week, and so that's what we're going to talk about today. Before we do that, I want to let you know that my name is Terry Grigsby. I am the owner and tutor at my tutoring business, Tag Tutoring Algebra and Geometry. And I mostly tutor high school, any algebra, geometry, algebra 2, integrated math, 1, 2, or 3, and I also do pre-calculus. So if you're interested in any of those, come by. Every week's not geometry week. Sometimes it's pre-calculus week. Sometimes it's algebra 1. Sometimes it's algebra 2. So you just don't know, but I will always post here on my YouTube channel and also here on Facebook what an upcoming event is. I'm trying to do them every Friday now. And so please come and join me. I love having you. So I see Christy is here. Hey, Christy, you're from Michigan. How are you doing? We got you through your math, didn't we, in college? That was so awesome. You were such a good student. And I was so proud of you when you got through that class. I was doing a happy dance on my end. So, hey, welcome. I'm so happy to see your name. That made my whole day, girly. Good for you. So the other thing I have to tell you before we start is I live in Beaverton, Oregon, but right by Portland, Oregon. And it snowed last night, but it didn't just snow. It iced first. And so I was out of power all morning. Yeah, I didn't think this Facebook Live was going to happen. I had to miss a tutoring session because of the ice and the power being down. And so hey, Robert from Maine, welcome. He's another awesome math tutoring guy. If you need calculus help, you need to go to Robert. I'm going to put your name up here so people can see it. And so you can take it in. Robert does excellent work with all the math, but he is a great calculus tutor. And I know when I have people getting to calculus, I am going to be looking you up. Because while I've taught calculus in the past, it's been too many years. And so I like to stick with what I'm really good at. And so look up Robert and he can help you out. Okay, so back to what I was saying. It's snowing. It never hardly snows in Portland, Oregon. And so we've got ice, we've got snow overnight. And now, you guys, it's raining, but it's only 28 degrees out. So you know what's happening? Yeah. It's icing over again. That's what caused the power outage before. So if we do happen to lose me, it is because ice is bringing down the power lines and I may be out of power again. But don't worry, we're going to keep going here. So yeah. So here I am, Terry Grigsby, if you're just jumping into the live today. If you're just jumping in, please tell us where you're from. And if you're a tutor, tell us what you tutor, and I'll put you up here and we can talk about that. Robert from Main Street Math Tutoring says it's 0 degrees. I know, in Michigan, like, this is nothing. Like, if you saw it, you would laugh so hard because it's like just a trace of snow. But the ice takes us down here in Portland, and the snow pretty much does too, because we're not used to driving in. In fact, this is the first snow we've had all winter long. We're supposed to get like 9 inches tonight. 9 inches in Portland, Oregon. That's hardly ever happened in my whole lifetime. So there you go. There you have it. So what am I here for? I am here for geometry. So let's do some geometry. And what I try to do on these lives is go over questions that I've been dealing with my people I've been tutoring. This week it's geometry, so I'm going to be hitting a geometry topic that we had to talk about. And so let's go over there. I'm going to share my screen if I can remember how to do this. Uh-oh, hold on. I have to do this right. I thought it was all set, but maybe I'm not. Okay, wait, maybe I'm okay. There I am. See, there I am. I'm going to go here. Okay, so what we're going to talk about today is vectors. And this isn't always in everybody's geometry class, but I'm noticing that it's showing up a lot more than it ever used to. This used to be like a pre-calculus topic. That's where I used to always see it. but it's showing up in geometry, and there's good reason for it. It fits perfectly with what you do in geometry, especially at this time of year. We're talking trigonometry a lot. And so I'm going to go over there to the whiteboard and talk to you a little bit about vectors. Now, if you happen to be popping in or you're watching this later and you're a geometry student or a parent of geometry student and you have any geometry questions, please put them in the comment section if you're on YouTube right now or on Facebook too. Put them in the comment section and I will do my best to answer those for you. And who knows, they may show up in the next live I do. You don't know. It could happen. It might happen. Okay, so let's talk vectors. So what in the world is even a vector? So here you can see me playing around because you're seeing my screen, but okay, I'm playing around till I get to what I need. Welcome to How I Tutor. This happens some days. Okay, so what's a vector? I'm going to lay one on you. Here's a vector. That is a vector. Oh yeah, it looks so simple. It is pretty simple. As you saw me draw that vector, you would have seen me, the arrow went in a particular direction, right? So every vector has a direction to it. Now you also saw me make it longer, didn't you, until it stopped. And so how long this is, I'm going to use a different color just so you can see it better. So how long this is right here, the length of it, well, that's the magnitude. That's what's called magnitude. And every vector obviously has to have magnitude because if it didn't, well, if it didn't have magnitude, how would you ever see it? That's a pretty good question, right? How would you see it if it didn't have magnitude? That's why it's in geometry, because you know, this really looks like a ray, doesn't it? But unlike a ray that you may have learned at the beginning of geometry, a ray has an arrow on the end because it's showing you it keeps going and going and going and going. That's not what it means in a vector. The vector has an arrow on it because it's showing you which direction it's going. So I could draw another vector and I could start at the end of this one. I'll draw it this way and have it be exactly the same magnitude. And you go, okay, that's a vector. That's the same vector. Well, first of all, it's not the same vector because it's green. Oh, okay, just because my other one's blue. I mean, that probably doesn't matter. But it's different because look what direction I made it. It's pointing the opposite direction from the original, right? My original blue one. It's going the same. It would have the same magnitude here. Let me put that. It has the same magnitude. And it definitely is. Oh, I can't spell magnitude. Definitely has the same magnitude, but it's going a different direction. Even if it's going exactly opposite direction, it's a different vector. So this is a different direction. So like all things, how do you name things in geometry for a vector? So my blue one, let me keep the colors going. Let me call that A. And to show somebody it's a vector and not just a point or a line, you put a handy dandy vector on it. But check out my vector symbol. It does not have the arrow going on the bottom. Why does it not go like this? Because in geometry, we know if you put a ray over something, it means you're talking, if you put a segment with an arrow on it, that means a ray, doesn't it? Now, technically, you would never name a ray with one letter. But so we have to tell the difference between a ray and a vector, so we only do half an arrow on top. Okay, that's just a little bit of language that you need to learn to be able to do vectors. So this one, I don't want to call it A. Let me call it something different. Let me call it B, but I'm going to tell you it's a vector because I'm going to put just one half of an arrow over the top. So the point of this is every vector has a direction and every vector has magnitude. Now, before we go to the next page, let's talk about how you would talk about a vector. So the most common way in geometry, you're probably going to mostly talk about it this way. You might say that the vector A, and I didn't draw anything to scale over there, could equal, I'm going to say 6, 4. I'm making that up, okay? That is not necessarily right for that. So first thing, more terminology. See how it has arrows on both ends? That's a version like parentheses, but when you see those, that's vector talk. That's telling you it's a vector. And what it's telling you is the x is moving positive 6, right? So it'd be going this way, 6. And then the other coordinate is y, and it's telling you it's moving plus 4, which would mean it's moving up 4. So this would be 4, this would be 6. And so that's different than if I said for B, let's say I put B over here, and I say it's going -6, -4. So that's telling you the x moves down, excuse me, the x is moving back 6, and the y is moving down 4, right? -4. So it's giving you the direction, just kind of like the difference is it's different than an ordered pair, because an ordered pair just tells you where you are from the origin. And this doesn't have to be true just from the origin, but we'll get to that. I'm going to go back and see if anybody else is here. Elaine from Ireland. It's my buddy Elaine from Ireland. It's so good to see you. So I'm going to put Elaine up here. There's Elaine. Look how beautiful she is. Elaine's another tutor of mine, and she also, I think you, oh no, now I'm going to botch this. I think you do reading and math. Is that correct? And what level are you tutoring? If you're still here, Elaine, let us know. But she tutors in Ireland. She has her own tutoring center, which I imagine got hit pretty hard with the COVID, like it did here in the States, having a physical place. Put in the comments for me, Elaine, if you see this, what levels you teach and tutor, and I'll let everybody know. Elaine, it's so good to see you. And again, if you're popping in here and if you have a question, please throw that in the comments and I will see that. And I'll give you a shout out like I did with Elaine and Robert. Okay, back to our program. So let's keep going. So you can see here some vectors. They can go every which direction you want. I'm going to move on from that because I want to do a little bit with you. So here we go. We're going to add some vectors, and they're telling me I have a vector 4, 2, and 6, -3. Now, I think I'll put this on a graph for you to start with so that you'll get the idea best. And I'm going to leave it purple. Yes, I am. Why? Because you may never in your whole life have ever seen a purple y-axis and a purple x-axis. And if you haven't, where you been, people? Use color. Color is fun. I can't live in a black and white world. I just can't do it. All right, so I could draw my first vector 4, 2. So I'm going to go over +4 from the origin, over 4, up 2. And so my first vector would look like that. Okay? Because notice, let me use a different color just to show you, that I went over 4 and then I went up 2, didn't I? So I went over 4, up 2. That's just to show you where we're going. So if it had been a -4, it would have gone a different direction, or a -2, it would have gone a different direction. Okay, and then let's add on this other one. I'm feeling the color today, you guys. And now I'm going to add that. So when you add vectors, there's a couple ways you could do it, but in geometry, you're probably going to do it this way. And that is you're going to start from the end of that first vector. So I'm going to start here, and I'm going to go over. Oh, I'm not going to use that. Hold on a second. I'm going to go to my vector thing. I'm going to go over 6, 1, 2, 3, 4, 5, 6, and then down 3 because it's negative. 1, 2, 3. Now that was just fun. That made my whole day. Okay, so on this vector, just to show you what I did and make sure we've got the idea right. Oh, I'll use green, I guess. I went over, let me turn this off. Hey, welcome back to my tutoring world. I'm going to use lines instead. So I'm go over 6, down 3. I tried to my best. So I went over 6, and then I went down 3. So notice that you don't have to start these vectors at the origin. I did the first one at the origin just to show you what's happening here. But you can start anywhere you want it. I could have put I could have put a 6, 3 vector, right? The wrong button. I could have started here and gone over 1, 2, 3, 4, 5, 6, and then down 3. And that would also be the vector 6, -3, right? So you can move vectors around, but you have to keep the direction the same and you have to keep their magnitude the same, or it's not the same vector. Okay? All right, so I'm going to get rid of that vector. Now for the good part, we're adding it, right? So now if I want to add this, let me use another color. I think I'll use this color. I'm going to start from the beginning of my purple vector, and I'm going to go to where the pink one ended. See why I did color there, guys? I'm going to try to make it a little more exact. A little hard on bit paper. And now the question of the day is, what are the components of this vector? Oh no. You guys know it's another vocab word of this new vector. I'm going to throw another word at you. This new vector is called the resultant. It's not even a shocking name. Like I tell my math kids all the time, math terms are not that shocking. They kind of a lot of the time mean the same thing they do in English. Result, the word result there is so what was the end result of putting the purple with the pink vector? That's what a resultant vector is. What are components? The components were, that's a component. It's telling me how the X moves and the Y moves. And that's a component too. So we have to come up with that same thing for our new periwinkle blue. I don't know if it is, but that's what I'm calling it. Periwinkle blue vector. So the reason I put it at the origin was for you to see how easily you do this. So it starts at 0. It went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it went over 10. But then it dipped down 1, didn't it? So I'm going to make it a -1 for its component. That's just looking at it in terms of geometry, right? That's all geometry. That's why you're starting to see this in a geometry class now. And then that's easy enough to do. So, but let's think about this now. I got 10, -1. Now let me show you how you would get this. So this right here, before we move on, this is the geometry version, okay? That's how to visualize it. That's how I think of geometry. Geometry is just a big visual, can you see what's going on in the world? When you look at something visually, it's geometry. If I want to talk about it in terms of algebra, which is what I want to do next, let me pick green. So if I think about this in terms of algebra, if I had 4, 2, and I'm adding on to that 6, 3, -3, excuse me, well, what if I added the X components? If I added 4 and 6, wouldn't I get 10? Cool. And then if I added 2 and -3, wouldn't that give me -1? Oh, yeah, baby. Yeah, baby, it does. And that, my friends, is the same as what we got visually with our geometry. So, important to know, this is called the head to tail method. I should probably put that on here. This is, let me go back to purple because that feels like my color today. So this is the head to tail method. And there's another one called the parallelogram method, but I don't want to get to it today because I think in geometry class, you're probably going to do it this way. And so you can stay tuned for pre-calculus and figure out how to do it there. It works exactly the same. It just looks visually different than it does here. So basically, to add 2 vectors, you add the X components and the Y components, and boom, there you are. So I'm going to go back, see if we have any other comments. Oh, here we go with Elaine. So here we go. Remember, she's in Ireland, and she says, yes, I tutor English reading and writing. I think that's her main thing, but she also does mathematics for 5 to 18, and she's completely online, and she was moving online well before the COVID hit. And so I'm really proud of her. She's made quite a great business for herself there. So if you're interested in Elaine for those little guys, especially reading and writing, you need to check her out because she is online. I don't know, Elaine, if where they find you online. You might want to put where I can find you now that you're back. And then I'll post that too. But so you've got a couple of good options. You got a calculus tutor now in the house, and you got a reading and writing and young guys math, and also my age math. We're different people, so that's that. So I'm not going to go and yabber on forever and ever and ever today. Let me go back to my banners. But I want to show you, if you're interested in finding out more about me, you should go to my website and check me out there. And there's tons of information about me. There's more videos about me. You can look on my YouTube channel. My YouTube channel is under Terry Grigsby, and I'll post that here. If you want to find me on YouTube, or if you're there now, you can find me under Terry Grigsby. I look like this. There's another Terry Grigsby there under YouTube, but find the one that looks like me, this white older lady. I don't feel older, but I guess I am. But join me over there. You can ask me questions there. If you are watching this on YouTube and you want to get hold of me, you can comment there that you might be interested in one-on-one tutoring. I do all mine online. I always have. So I've been doing it for about 4 years. And just to give you a little background on me briefly, I taught high school. Oh, yes, I did. I had a blast doing it. I taught high school for 20 years. And then I taught college for 10 years. And I taught college algebra there. That's what I was helping Christy with, who we introduced earlier in this talk today. So I do both. If you're interested in college algebra, I can help you with that too. So this is just a quick little overview of Vector today, but I'd love to help you more if you need more help with that. That was just a very brief thing just to show you how I teach and a little bit about what vectors look like. You guys, I'm going to leave you for today. I didn't see any questions. Let me see. Oh, here we go. Before we go, don't leave yet. Here's how you find Elaine to get that reading, writing, and arithmetic over there in Ireland. And you know what? I don't know how to say your town name. Bundoran is what I think you would say. Bundoran. Bundoran? It's probably Bundoran, but I don't know. It's the same. It's the same place. That's where she lives. It's a coastal town. Oh my gosh, they're beautiful pictures. If I ever find a way, I am going to Ireland and visit you, my friend, because I've never been to Ireland and I'd love to go. I'm half Irish, so why am I not going to Ireland? I ask you. Okay, I'm going to stop jabbering on and I'm going to let you people go. You have a wonderful Friday. Have a great week. I'll see you here next Friday, same time, 1 p.m. Pacific Standard Time, and I'm going to let you go. Bye, everybody.